in this tutorial we're going to look at 3D Pythagoras. If you are not confident with Pythagoras theorem, then just have a quick look at the Pythagoras tutorial where it just goes over the basics of it. For 3D Pythagoras you don't have to do much apart from you need to do Pythagoras twice. So let's have a little look at this first one here. This breaks it up into the different steps that we need to do. So answer the following about the cuboid opposite. So if you can see this cuboid, there's obviously some lines being drawn in the middle of it which we're going to use. So calculate the length of the face diagonal AC. So this face on the bottom, that's why we call it the face diagonal. We're just looking at getting AC. So we know it's a cuboid, so we know that that angle in there is actually a right angle. So we can draw that triangle out. So taking it up from the face ACD, I'm just going to draw a quick sketch as a right angle triangle. And from, just so you can see that. So I'm drawing A, which is down here, along to D there, up to C there. We know that this is 11 and this is 4 centimetres. So the first thing we're going to do is calculate the length of the face diagonal AC. So AC is the hypotenuse, so C squared equals A squared plus B squared. So C squared equals, doesn't matter which one you use first, 4 squared plus 11 squared. So C squared equals 4 squared plus 11 squared, 137. And so C equals the square root of 137. Now I'm actually going to leave it as a square root just because we're going to do 3D Pythagoras, which means we're going to be using this in just a second. You'll see why I've left it as a square root. So if you're doing 3D Pythagoras, just leave this one as a root. So that's root 137 centimetres. So I've got the first length. It then says, hence calculate the length of the space diagonal AG. So A to G, going from this corner up to that back corner. So I don't know if you can see on this, but if we could get a right angle triangle here by going along the face diagonal we just found, up to AG and then down there. So this is why we found the first one, so that using 3D Pythagoras we can then find the long one that we're trying to find in part B. So I've drawn here G down to C and along to A. So this length AC at the bottom is the one we've just found here, which is the square root of 137. This one here is 5 centimetres. And so once again we're looking for the hypotenuse. C squared equals A squared plus B squared. Maybe I'll just put in that that's AG squared because that's the one we're looking for, equals 5 squared plus, and then this is why I've left it as a square root, because we're just doing the square root of 137 squared. It keeps it nice and accurate because the square root of 137 then squared just gives us 137. Whereas if we'd rounded this answer before, we'd start to lose a little bit of accuracy. So AG squared equals, you can put it in 5 squared plus, you can either put in the square root of 137 squared or just put in plus 137. So AG squared equals 162. That means that AG equals the square root of 162. Because this is our final answer, I am going to write this out. So it's 9 root 2. So you could leave it as an unrounded, just like a simplified third. Or you can leave it here as the decimal. So 12.727 ... Just be careful if the question does, and it often does, just ask you to leave it as a third. So 12.7 centimetres, I'm going to leave that too. And so that's how we use 3D Pythagoras. You're going to use it twice. Let's look at 2 more. I'm going to do one more from this worksheet. So we're going to do the next one, and then I'm going to look at a past paper question. So the pyramid opposite has a rectangular base. Calculate the length of the base diagonal PR. So PR, as you can see, once again, because it's a rectangle at that base, that angle there is a right angle. So we can just draw out this triangle here. So I'm going to draw out PSR. It's just a sketch to help me visualise it. So 16 centimetres on the bottom, 12 centimetres there. And we're finding PR. So we're finding the hypotenuse again. C squared equals A squared plus B squared. PR squared, because that's what we're looking for, equals 12 squared plus 16 squared. So PR squared, 12 squared plus 16 squared is 400. So PR is the square root of 400, which if it wasn't an exact answer, I might just leave as a third, square root of 400. I know that the square root of 400 is 20, so, is 20, so we're not losing any accuracy if we do change it to 20 there. That's fine. If this was an answer that had lots of decimal places, I would just leave it as the square root in the square root. All right, so given that TR equals 18 centimetres, calculate the vertical height of the pyramid. So this is a little bit different this time. We're still using 3D Pythagoras. T down to the base there, along to R, T. We know that in there that's going to be a right angle. So we're just going to draw this out first. So I'm going to draw T down to the base, R. So that's T, that's R, and that's our right angle. We've been told that this is 18 centimetres. Now, we've just found in the last bit, P to R, all the way along from P to R. And as you can see, those two little lines means that they're both the same length. So actually here is going to be half of what we found before. What we found before was 20 centimetres, so here is going to be 10 centimetres. So this time we're looking for a shorter side. So you rearrange the Pythagoras theorem so that you've got a short side, A squared equals the hypotenuse squared minus the other short side squared. So A squared equals 18 squared minus 10 squared. A squared equals 18 squared minus 10 squared, which is 224. So A equals the square root of 224, which you can leave as a third, 4 root 14, or we can write it as 14.9666 dot dot dot, which is going to round to 15.0, so we can just write 15 centimetres. And so the height, just to put it back into the context, is because it just says calculate the vertical height of the pyramid. So we can write that the height is 15 centimetres. Right, so that's how we use 3D Pythagoras. I'm now going to look at a past paper question that used this, and this is from the 2018 paper. So it says, Chris wants to store his umbrella in a locker. The locker is a cuboid with internal dimensions of length 40 centimetres, breadth 40 centimetres, and height 70 centimetres. The umbrella is 85 centimetres long. He thinks it will fit into the locker from corner P to corner M. Is he correct? So let's just visualise this. So corner P down to corner M. He thinks it's going to fit from that back corner down to the front corner. So this is the diagonal through space, but we know we can find that space diagonal, the one through space, if we find a face diagonal and use Pythagoras twice. So up here, I'm going to create another right angled triangle on that square base at the top that we know, and I'm going to pull out a right angle triangle so that we can find that length to then find this long one here. So I'm going to pull out this triangle here. It's not quite an accurate sketch, but we do know that that's 40, that's also 40, so we've got 40 centimetres, 40 centimetres, and then we're going to find this face diagonal, the one that goes along the top square. So using Pythagoras, we've got c squared equals a squared plus b squared. C squared equals 40 squared plus 40 squared. So c squared equals 3,200. So c equals, and I don't think, no, I know. So that's the square root of 3,200. And I'm just going to leave it like that to keep it nice and accurate because we know we're going to use it again. Square root of 3,200. All right, now I'm going to pull out this triangle here. So we can see that in there would be a right angle. Don't know if you can see that well. I'm just going to pull it out the way I've drawn it up there so that it makes sense. So this length that I'm drawing here is this one here. Then I'm going to draw it flat on so we can imagine the right angle triangle. And then this diagonal here that I'm drawing the hypotenuse is the diagonal from this corner down to this corner. So I've drawn this diagonal, this triangle here. So that's our right angle. This is the height, which is 70 centimetres. And this one here is the one that we have just found. So root 3,200. So to find that diagonal through space, we're going to use Pythagoras again. C squared equals a squared plus b squared. So c squared equals 40 squared plus 3,200 squared. So by not finding what that is, we've kept the accuracy there. So c squared equals 70 squared plus 3,200, because we know square root of 3,200 squared, they've cancelled each other out. So that's 8,100. So c equals the square root of 8,100, which you've probably seen is going to be 90. So c equals 90 centimetres. Going back to the question, the umbrella is 85 centimetres long. He thinks it will fit into the locker from corner P to corner M. Is he correct? So yes, he is correct. As there is space for 90 centimetres between corner P and M. And that's you. That's you used 3D Pythagoras and you're ready to try some on your own.